Imagine standing on a planet where the sun looks golden, the sky is pitch black, and the temperatures swing between blazing heat and freezing cold. Welcome to Mercury. Why does Mercury have no moons, no atmosphere, and yet still manages to have ice? How can a planet so close to the sun have ice on its surface? Did you know a single day on Mercury lasts longer than 2 of its years? Let's find out why. The sun is right in front of us. Let's keep moving. At this point, remember that we are over 70 million kilometers away from Earth. The journey ahead is so fascinating that there's no thought of turning back. The heat from the blazing sun here is unbearable. It might seem like we shouldn't be here. But wait. That tiny dot gliding across the sun's golden surface is Mercury, the first and smallest planet in our solar system. The view of the sky from Mercury is extraordinary. Unlike Earth, where the sky appears blue, Mercury's sky is pitch black, darker than the darkest night. You won't find Earth's familiar blue skies here. In fact, did you know that the true color of the sky is black? Scientifically speaking, what we call the sky is just an infinitely vast space without any inherent color. So why does the sky on Earth appear blue? To understand this, you need to know that sunlight is made up of 7 colors. Each color has a different wavelength. Red has the longest wavelength, while blue and violet have the shortest. When sunlight enters Earth's atmosphere, it interacts with oxygen and nitrogen molecules. Colors like red, orange, yellow, and green have wavelengths strong enough to pass through these molecules and reach the ground. However, blue and violet, with their shorter wavelengths, scatter in all directions after colliding with the molecules. This scattering is why the sky appears blue to us. But why don't we see violet instead of blue, given it also scatters significantly? The answer lies in the biology of human eyesight. Our eyes are more sensitive to blue wavelengths than violet, making blue more noticeable. So, even though violet is present in the sky, it's invisible to most humans. Interestingly, some animals like honeybees and falcons can detect every wavelength, including violet. Perhaps they perceive the sky as violet, as seen in this image. On Mercury, however, sunlight shines directly onto the surface without being diffused by an atmosphere. From there, the sun appears golden, and the sky remains pitch black. Mercury has no atmosphere and, like Venus, no moons. Its weak gravitational force prevents it from capturing any large objects, such as moons or asteroids. Instead, meteorites either crash into Mercury or are pulled into the fiery sun, which lies 35 million kilometers away. This is because the sun's immense gravitational force dominates the region. An object's gravitational force is proportional to its mass, and Mercury's small size means its mass is only 6% that of Earth's. However, its gravity is about 40% of Earth's. For example, if you weigh 70 kilograms on Earth, you'd weigh just 30 kilograms on Mercury. It sounds like a great place to lose weight. But the problem is, you might not make it back to Earth to show off your new figure. Even if you plan to visit Mercury for weight loss, don't stay longer than a day. Mercury's days are extraordinarily long, and its years are incredibly short. A single day on Mercury lasts over 2 Earth years. Mercury takes 176 Earth days to complete 1 rotation on its axis, roughly 6 months. Yet, it only takes 88 Earth days to orbit the sun. This means a day on Mercury outlasts 2 of its years. As the planet closest to the sun, Mercury lives between 2 extremes. During the day, temperatures soar to a scorching 800 degrees Fahrenheit, while at night they plummet to a frigid negative 275 degrees. It's the price Mercury pays for being the sun's closest neighbor, orbiting the king of the solar system. Interestingly, despite its proximity to the sun, Mercury currently has no active volcanoes. In the past, however, volcanoes did exist, but they are long extinct, leaving the planet barren and lifeless. For this reason, Mercury is often referred to as a dead planet. It lacks fire, an atmosphere, and even a magnetic field. Yet, Mercury still surprises us. Even in the intense heat near the blazing sun, this seemingly desolate planet has ice deposits at its poles. Yes, you heard that right. Ice on Mercury. The discovery of ice here was astonishing, particularly because Mercury lacks an atmosphere and orbits so close to the sun. In 1991, radar detections first hinted at the possibility of ice, leaving scientists baffled. How could a tiny planet so close to the sun sustain ice? The mystery led to years of research and substantial investment. Finally, in 2012, NASA's Messenger spacecraft confirmed the presence of ice on Mercury, capturing detailed images that proved its existence. This ice is found in deep craters near Mercury's North Pole, areas that have remained in permanent shadow for billions of years. Because these regions never receive sunlight, the ice has stayed frozen, untouched by the sun's searing heat. The discovery of ice sparked excitement among scientists searching for life beyond Earth. Some even speculated about the possibility of microscopic life, cells, bacteria, or other organisms hidden in the icy layers. However, NASA's missions, including Mariner 10 and Messenger, found no evidence of life on Mercury. Mariner 10, after 21 years of service, has since retired and now drifts aimlessly in orbit around the sun. The Messenger spacecraft, a robotic mission, sent invaluable data and stunning images of Mercury for 4 years. It concluded its mission in April 2015 by deliberately crashing onto Mercury's surface. Much of what we know about Mercury today comes from the data and images provided by Messenger. While life remains undetected, the discovery of ice on Mercury has opened new possibilities for scientific exploration. This raises a crucial question. How did this ice form on Mercury? The answer lies in the same processes that brought ice to Earth billions of years ago. But how did Earth itself receive ice? And why is there talk of building a massive shield around the sun? What's the purpose of such a plan, and could it even be possible? These intriguing mysteries lead us toward another exciting destination, a planet where humanity is planning its next great leap. Could it be a place we originated from? How will humans reach this planet? And what will life there look like? We'll explore all this in the next part of our series.